Today we're going to continue looking at section 5.1, which is all about angles and radian measure. So today we're going to now start drawing angles in standard position. We're going to find something called coterminal angles, and we're going to find the length of a circular arc. So we mentioned what standard position was in the last video. Remember that the vertex has to be at the origin. You have to have your initial side on the positive x-axis, and then your terminal side can be wherever. And then we're talking about, do we go clockwise or counterclockwise, depending on if the angle's positive or negative. So now that we know a little bit more about converting back and forth between radians and degrees, it is helpful to have that information. However, it is going to be super important that we just begin thinking about things in terms of radians and not trying to convert it into degrees. Okay, so we have to think radians. And so that's how I'm going to be practicing a lot of the information. And we're going to drill it and drill it and drill it until we understand and think like radians. But here are 4 crucial radians to know. So on the far left here, notice that we have one full circle. So notice that the blue side is the only side that we see because the terminal side is on top of the initial side. And notice how we have one loop around, and that's one revolution, which means that it's considered 2 pi radians. Because remember, 2 pi in terms of radians was that 360 degrees. It's one full circle. So over here, the next picture, notice how my initial side is on the positive x-axis. We are going in a counterclockwise position. So right now this is representing a positive angle. My terminal side is that darker arrow on the y-axis. We have gone 3/4 of a revolution because we've hit 1, 2, 3 quadrants. So it's 3/4 of a revolution. And so if you think about 3/4 of the full revolution of 2 pi, it's going to then simplify and become 3 pi over 2 radians. If I look at the third picture, we are talking about going half of the circle. So starting on the positive x-axis and ending on the negative. So if we are having half of a revolution, we're taking half of 2 pi. So that means that we have pi radians for half of a circle. Then if I look at the far right, my initial side's on the positive x-axis. My terminal side is up here on the positive y-axis. We are only going from one axis to the other. We have 1/4 of a revolution. So 1/4 of the entire circle, 1/4 of 2 pi, if I was to multiply straight across and reduce, would give me pi over 2 radians. So those 4 values are going to be crucial, and they're what we're always going to be referencing when we are drawing our angles in standard position. So let's just jump into it. Let's draw and label each angle in standard position. And notice how we're going to be really practicing radians. You might have some degrees in your homework, but I just want to just do radian after radian after radian so we can make sure that we're understanding this. Okay, so if I want to draw theta to equal negative pi over 4, what we're going to do when we're drawing is I got to have an x and a y axis, where I need to remember that what one full rotation is. So it starts at 0 radians over here on the positive x-axis. Notice I don't have a degree symbol because I'm talking radians. And then we have one full rotation, which will land me back here, is 2 pi. Okay, however, in this particular problem, notice that we have a denominator of 4. So what I like to do with these problems is I like to take 2 pi, which we know is one full rotation. I like to then think about it in terms of, well, I want the same denominator as the denominator of my problem here. So since 4 is the denominator of this radian value that we want to draw, I want to convert 2 pi into a fraction with a denominator of 4. So think about this. How did you go from technically a denominator of 1 into a denominator of 4? Well, I multiplied by 4. If I do that to the bottom, I have to do it to the top to keep that fraction balanced. So 4 times 2 pi is going to give me 8 pi. And hopefully that makes sense. 8 pi over 4 is, if I were to divide that, is really 2 pi. Okay, so those are equivalent. So the next thing I like to do is I like to go over to the halfway mark, which remember, halfway is always going to be pi. Okay, now notice that in this problem, we are dealing with a negative. So that means instead of it being a positive pi, I want it to be a negative pi. And once again, I kind of want to think about it in terms of a denominator of 4. So what's going to make something be divided by 4 and essentially turn into a negative pi? Well, that would be a negative 4 pi over 4. Okay, so I'm going to erase the negative pi and I'm going to think of it as negative 4 pi over 4. Okay, because that just simplifies down to negative pi. When we're talking about negative angles, remember that means we want to move in a clockwise position. So that means I want to start at 0 and I want to move heading down so then I can loop around in a clockwise position. So to go from 0 to halfway being negative 4 pi over 4, well, I'm going to then want to know what's halfway between 0 and negative 4 if I just focus on the numerator. Well, halfway between 0 and negative 4 would be negative 2. So really down here, it's negative 2 pi over 4. If I then loop around, so notice that essentially then every single quadrant, I'm going to be subtracting 2. To go from 0, when I subtract 2, there's my numerator. When I subtract 2 from the numerator, I get to negative 4. I'm going to take negative 4, I'm going to subtract 2 again, and that's going to take me up here to negative 6 pi over 4. Notice that if I continue to move, if I go negative 2, well, then that's where this negative 8 pi over 4 is. Okay, I needed it to be negative because we're moving in a negative direction here. And then I could keep going. I could keep subtracting 2 from each of these, and I could keep going around and around and around and around. And that's where each of these quadrants then have particular angles labeled. Okay, so now that I have my different axes labeled, now I can actually draw my angle in standard position. So to do that, let me change colors here. Remember, I always want my initial side on the positive x-axis. And then now I just need to figure out where my terminal side is going to go. Well, it's really the numerator. So let me change colors here. Notice how it's the numerator. So technically, this is like a negative 1 pi in the numerator. I want to look at all the numerators of the fractions that I just drew, and I need to figure out where negative 1 is going to be. Well, hopefully we notice that negative 1 is going to fall between 0 and negative 2. So I know that my terminal side is going to be right here because once again, negative 1 pi over 4 is going to be halfway between 0 and negative 2 pi over 4. So that's where my terminal side is. The last thing that I have to show when I'm drawing this picture is I need to show the movement of the terminal side. So remember, it always starts on the positive x-axis, and because we are dealing with a negative angle, we were moving in a clockwise position, and so it was a very short rotation, but that is where theta is. So I know that was a lot of information, but that is a picture of my angle in standard form. Okay, so let's take a look then at this next example. This time I want to draw alpha at 13 pi over 4. Okay, so once again, to draw my angle, I need to have an x and a y axis, and I want to label these axes. So I always have 0 starting us on that positive x-axis. And once again, the nice thing about this example here, looking at my denominator, I have a 4, so it's going to match what we had in the last problem, where if one full rotation is 2 pi, I can turn it into a denominator of 4 by multiplying the top and the bottom. I know that 1 full rotation is 8 pi over 4. Notice that in this example, though, my angle is a positive, which means I want to be moving in a counterclockwise position. So when I move and go halfway, this is now a positive pi, which is 4 pi over 4. Okay, because half of 8 would get me 4. So that's why 4 is in the numerator. So that means that now if I'm moving in a counterclockwise position, halfway between 0 and 4 would give me a positive 2 pi over 4 on the top. So once again, notice that it's really me taking my numerators and I'm really going to be adding 2 onto each of them, because from 0 to 2 gets me that 2 pi over 4. Add 2 more and that gets me 4 pi over 4. Add 2 more onto the numerator and I get 6 pi over 4. Add 2 more, there's my 8 pi over 4. If I look at the number in the numerator of the angle I'm trying to draw, the issue is 13 is bigger than 8. So that means that I'm going to have to keep going with my counting of 2's. So from 8, if I count 2 more, this is really also 10 pi over 4 on the top. If I count 2 more over, I've got 12 pi over 4 on the side. If I count 2 more over, I'm at, not 13, but I'm at 14 pi over 4. If I count 2 more over, I'm at 16 pi over 4. That definitely is enough because 13 is going to fall within that scope of numbers. So I can stop at that point. Okay, so now I'm going to draw each of my sides. Once again, my positive initial side here on that positive x-axis. And now I want to figure out where is that positive 13 going to fall. So if I'm looking at all of the numerators, I notice that over here in the third quadrant is 12 pi over 4 to 14 pi over 4. That means 13 pi over 4 is going to fall in between them. So 13 pi over 4 is going to be over here in the third quadrant. Now I need to do my loops. Okay, so think about it. My loop is going to go in a counterclockwise position because the angle is positive. I am going to start at the initial side, but remember, if I'm looking at my numerators, I have to go not only 1 full rotation, because that only takes me to the 8 pi over 4, but then if I keep going up here, there's my 10 pi over 4. Keep going, there's my 12 pi over 4. And then finally, I can stop at that terminal side because that's 13 pi over 4. So sometimes it's going to be quite a few loops. You just have to be very careful. So notice that that is my alpha, and there is my standard position angle. All right, so let's look at this next couple problems here. I have different denominators, so hopefully the explanation of how I can get there is going to be helpful. Okay, so if I want to draw theta to be 4 pi over 3, once again, I want my x and my y-axis, and I want to start labeling it. So in order for me to label, which I know I'm going to start at 0, I look at my denominator of my radian. It's 3. So what I want to do, if I know 1 full rotation is 2 pi, I want to turn it into a denominator of 3 because that's the denominator of my radian that I'm dealing with. So how did I go from a 1 to a 3? Well, I multiplied by 3. If I do that to the bottom, I have to do it to the top as well. So 3 times 2 pi is going to give me 6 pi. Notice that my angle is a positive, so I know that I can keep it a positive. 6 pi over 3 is where I end up as well as where I started at 0. Okay, so now because I know that I'm dealing with a positive angle, I know that I'm going to be going in a counterclockwise position. Halfway is going to be half of 6. So that's why 3 pi over 3 is going to be the halfway mark over there on the negative x-axis. Okay, so now this is where we have to think. I need to know what the number is up here at the top. Well, that's halfway between 0 and 3. Well, what's halfway between 0 and 3? Well, 1.5. So this is 1.5 pi over 3. So it's not the prettiest number because it's a decimal, but remember, that means that each quarter of the way, I'm going to add on then 1.5 because 0 plus 1.5 gets me that at the top. 1.5 plus 1.5 is going to get me 3 over here on the left side. So I'm going to add 1.5 onto 3. So then we'll have 4.5 pi over 3 down here at the bottom. And then notice that if I add 1.5 onto 4.5, that's going to take me to 6. Because my numerator is 4, I have plenty of numbers here because 6 pi over 3, 6 is bigger than 4. I don't have to keep looping around and adding on 1.5 to each of my numerators. I can stop after that first round. So what I want to do is I want to draw my initial side here on the positive x-axis. And now I want to draw my terminal side. So I want to figure out where's 4 going to fall. Well, notice that if I look at all my numerators, 4 is going to be between 3 and 4.5. But it is going to be a little bit closer to the 4.5. Okay, so there's where my terminal side is. It falls in the third quadrant. And now I have to do my loop. So remember, 6 pi over 3 is one full circle. I don't have to draw a full circle because 4 pi is smaller. So from the initial side, I just have to have my counterclockwise rotation until I get to that third quadrant. And that is the picture of my angle in standard form. Okay, if we take a look at this next example, I have 6 for the denominator. Okay, so here, let me sketch my x and y axis, and then let's talk about how we would label these different pieces. So remember, if I'm dealing with 6 for my denominator, one full rotation, it starts at 0, but it ends at 2 pi. I want to turn 2 pi into a denominator of 6. So how did I go from 1 to 6? Well, I multiplied the bottom by 6. If I multiply the bottom, I got to multiply the top. So hopefully we're okay with noticing that it's really 12 pi over 6. That is one full rotation. So if I want to go over then halfway, what's half of 12? Well, it will be 6. So 6 pi over 6 is going to be that halfway part. But then notice that this problem, my angle is negative. So I actually want negative numbers here instead of positive numbers. But then remember, because we're dealing with negatives, I want to be moving in a clockwise position. So when I want to figure out the halfway mark between 0 and -6, I have to put that at the bottom. Halfway is going to be -3 pi over 6. Then if I notice to go from 0 to -3 is a distance of -3, notice -3 minus 3 got me -6. I'm going to subtract 3 from -6 to get -9. So we'll have -9 pi over 6. Notice that once again, if I add on -3, I'm going to get to that -12. I know that I'm good to go there. I don't have to do anything extra because hopefully we notice that this is really a -1 in the numerator. Okay, and so I definitely have -1 covered in everything that I just labeled. So I can draw my initial side on the positive x-axis, and then I now need to know, where does -1 fall in this picture? Well, -1 is going to be between 0 and -3. It's going to be closer to 0 than it is to -3. So my terminal side is going to be here in the fourth quadrant. Once again, I am then wanting to do my loop. I can do a very short loop because it starts at the initial side, and -1 is going to be very, very close to 0. And so that right there is my alpha, and there is my picture. Okay, so try this the best that you can, but remember, we will do more practice in class. So if you're still stuck on something, Definitely ask questions in class, but this is the thought process for drawing angles. And like I said, I practiced all of them in radians. There are going to be some examples where you want to think of it in terms of degrees, and maybe that would be a little bit easier for you to think about. Okay, moving on. I would suggest maybe just pausing the video. You don't necessarily have to write this all down. This is something that you will definitely have to write down later on, but because it's something that you're going to memorize, this is something called a unit circle. But like I said, we're actually going to talk through this more later on, and we're going to recreate this unit circle. So these are just different values that are going to be important to know, like the angle measures that we want in degrees, like 30, 45, 60, 90, and so on and so forth. The radian values that are going to match with it, we're going to have to know those backwards and forwards. Okay, so let's move on to the next concept, which is coterminal angles. Two angles with the same initial and terminal sides, but possibly different rotations, are called coterminal angles. Okay, so depending on if we're talking degrees versus radians, I've got two definitions here for you. If an angle is in degrees, to find its coterminal angle, whatever the angle is, we're going to add or subtract 360 degrees as many times as we need to. So that's what the K is, until we can get down to a particular number. And I'll explain more in a second when we do examples. But if we're talking about degrees, we're thinking one full rotation is 360 degrees. So we're going to be adding and subtracting 360 from the angle that I give you. If we're talking about an angle in terms of radians, well, remember, one full rotation is 2 pi. So I'm going to be adding and subtracting 2 pi. Once again, K is telling me the number of times I'll have to do that. Okay, it'll depend on the problem that we are dealing with, but we're going to be adding and subtracting 2 pi onto the angle that I give you. So let's just dive into some examples. So we'll start with degrees. It says find a positive angle less than 360 that is coterminal with each of the following. Okay, I can't stress enough, it has to be a positive angle. So our final answer will never have a negative, but it has to be a number that's smaller than 360. So if I look at the first example here, we're talking about a 400-degree angle. Well, notice that 400 is definitely bigger than 360. So if I need to have a positive number, but it's smaller than 360, I'm going to take the angle that they give us, and in this case, I have to subtract 360 from it. When I take 400 and I subtract 360, that is going to give me 40, okay? That is in degrees. Notice that this angle is positive and it's smaller than 360. That is the hint then that we are done. If I tried to subtract 360 again, I would get a negative number, and that doesn't meet the requirements that I'm asking for. I need a positive angle. So 40 degrees is the same thing then as 400 degrees as far as the look of the angle in standard position. The next example here, I have negative 135. So because I'm starting with a negative angle, I want my answer to be positive. Well, how do I go from something negative to positive? I'm going to add onto it. So I'm going to add 360 degrees onto this. So negative 135 plus 360, this is going to give me 225 degrees. I added once and it was enough to get me a positive number. 225 is less than 360. So once again, it only took me doing it one time, but that is my answer. Okay, had the number been like negative 600 and something, adding 360 once wouldn't make that number positive. So then I would have to add it again. I would have to keep adding 360 until that number is positive, but smaller than 360. So let's do the same thing, but let's look at it in terms of radians. Once again, we want to have a positive angle, but now we're talking radians, so it has to be less than 2 pi. So we're going to kind of think about it the same way as we did with the drawing of the angles. I want to look at the denominator of the angle that we're starting with. Because my denominator is 5, I like to do some converting. So 2 pi, if I want a denominator of 5, well, that meant that I had to multiply the denominator of 1 by 5 to get 5, which means I have to multiply the numerator by 5 as well. So 2 pi is the same thing as 10 pi over 5. So notice that 10 pi over 5, the number on the top is smaller than the number that is on the top of the angle that is given to us. That means that 13 pi over 5 is bigger than 1 rotation. So if I need to make it less than 2 pi, I'm going to subtract 10 pi over 5. The nice thing about having then that common denominator is I get to leave the denominator and I just have to subtract the numerators. Those are like terms. 13 pi minus 10 pi is going to give me 3 pi. Because the number on the top is positive and it's smaller than 10, which is that magic number because that's 2 pi, that means that this is my final answer. Okay, if I look at the next example, I see that there is a 15 for my denominator. So I want to take that 2 pi and I want to convert it so it has a denominator of 15. So that means that I had to multiply 1 by 15, which means that the numerator has to get multiplied by 15. 15 times 2 pi is 30 pi. So that's the number that I need to add and subtract in order to then find this positive coterminal angle. So notice that my number is a negative. It's technically like negative 1 pi. All right, so because we're dealing with a negative number and I want a positive answer, I'm going to add this 30 pi over 15 onto that original angle. Once again, with them having the same denominator, I get to keep the denominator of 15 and I can combine my like terms. So I have negative 1 pi plus 30 pi. That's going to give me a positive 29 pi. My number in the numerator is positive and 29 is smaller than 30 because 30 is that magic number. So once again, it just took us one time and we have our answer. Just remember, it's not always going to just be one time. Sometimes you might have to add or subtract more than once. So just be aware of that. But that's how we find a positive coterminal angle. So then the last concept that I want to talk about is length of a circular arc. This formula should hopefully look pretty familiar to you. It says let r be the radius of the circle and theta is a non-negative radian measure of the central angle of a circle. To find the length of an arc intercepted by the central angle, we take s equals r times theta. So like I said, hopefully this kind of looks familiar because we had a formula in the last video where to find our theta, we took the arc length and we divided it by the radius. So this time they just manipulated the problem. They just multiplied both sides by the radius, and that's why now S is going to equal R times theta. All right. But notice how it specifically says that it is a non-negative radian measure. That's going to be important. If theta is not positive, we have to fix it to be a positive number. If theta is not given to us in radians, we have to turn it into radians first. All right, so let's take a look at this problem. It says find the length of the arc. So once again, since I don't know the length of the arc, that is S. That's what I'm trying to find. And so from the formula we just talked about, I want to multiply theta and the radius together. Notice that the radius in problem 1 is given to us as 16 inches. The central angle is given to us as 60 degrees. Here's the issue. While that is a positive number, which is a good thing, it's not radians. I need radians in order to actually complete this problem. So that means we have to do some converting. Remember, 60 degrees. I need to multiply that by pi radians in the top and 180 degrees on the bottom. Remember, the whole point is that the degrees will cancel. I can multiply straight across. That gives me 60 pi over 180, which then simplifies down to pi over 3 radians. So that is really my theta. So to find my arc length, we are going to take my radius, which is pi over 3, and we're going to multiply it by 16. So the directions say to first state the answer in terms of pi, and then use your calculator and round to 2 decimal places. So if I want to keep it in terms of pi, I can think of 16 as 16 over 1. I multiply straight across. That would give me 16 pi on the top and 3 on the bottom. 16 and 3 don't divide into anything where I can reduce those numbers. So this would be my final answer in terms of pi. If I then take my calculator and divide and actually use the pi button, okay, don't do 3.14, but multiply the 16 in pi and then divide by 3 to 2 decimal places, it would be 16.76. I guess I forgot to write. I want to put my units. Because we're talking length, we're talking about whatever the units are for the radius. So I want inches for both of these. Okay, so those are my answers. Okay, same idea with the next one. They're giving me the radius. This time it's 9 yards, but my central angle, I need to turn it into radians first. So I take 315 degrees and I want to multiply it by pi radians over 180 degrees. When I multiply straight across, 315 is now with pi, 180 is on the bottom. Remember, the degrees canceled. When I simplify that down, that's going to simplify down to 7 pi over 4. So that's the theta that we really want to use. So once again, to find the arc length, I take that theta, so 7 pi over 4, and I want to multiply it by, this case, the 9, because that's the radius. So I can put it over 1 to multiply straight across to get my answer in terms of pi. That would give me 63 pi over 4. I can't reduce down the 63 and the 4. My units are yards. So there's my first answer. If I then carefully type that into the calculator and round to 2 decimal places, I'm going to get 49.48 yards. So those are my 2 answers, both in exact form as well as rounded. Okay? So that's us drawing angles in standard position, finding coterminal angles, and finding length of a circular arc.